This is a tutorial to show how to identify the nature of mutations in the plasmid DNA for bio125 spring 2014 at Spelman College. So first we're going to go to a Moodle site, download the sequences. So make sure you know where the file are downloaded to. In my case, it goes to my download folder. After you download the file, make sure the zip file is completely extracted. So in some of the Windows system, you want to right click on it, then select extract all. In Mac, you can just double click it. So in the plasmid sequences, those are the plasmid sequences we provide you. PMSH2 is the wild type, and then those are various mutant. So I'm going to first open up the wild type and make sure this is a circular. And then I'm going to identify the MSH2 open reading frame, which the MSH2 open reading frame was demonstrated in a previous video. So it's basically is the sequence from 3378 to 6302. So I highlight it. That's basically the wild type. And then for the mutant, I'm going to pick one mutant as an example, AG29. And then I'm going to use align two sequences to find out where the mutation is first. So mutation of is here. So you see the that's end at 5,000. So it says 5,001, 1, 2, 3. So there. So that's the mutation is from 5001 to 5003. So that's where the mutation. Now the question is ask you to identify what kind of mutation this is. So we need to translate the coding sequences, the operating frame into the protein. So I go back to the plasmid DNA and then select again from 3378 to 6302. This is my mutant AGH. In fact, we can annotate this one. This will be mutant MSH2 AG29. Okay. And if we look at the map again, oh, I forgot to click this as a circular side. So this is our mutant. So 3378 to 6308. Remember, the mutation is around 5,000, so it's right in the middle of MSH2. How do we find out the nature of the mutation? We will first translate this into protein. Translate. Okay, so make sure the translation is in the right coordinate. So this is 3378 to 6302. And I'm going to scroll down, make sure there's no premature stop codon. So that looks right. Now, then we also need to translate the wild type. So go back to the wild type plasmid and select the same position. Okay. And then do translation. Same translation. Now we can compare the wild type is 975, a mutant is also 975 amino acid in length. So this looks like a missense mutation. Now we just need to align the two protein sequences and then find out the nature of the mutation. And to do the alignment, so I'm going to go to Google and find out the EMBL Clustal. So Clustal W2 multiple sequence alignment provided at the EBI and EMBL side. So now the trouble is we need to put two protein sequences into the one window. If we just copy paste the sequence directly, that the two sequences going to be handled as one. So how do we put two sequences into one window? This is something called a FASTA format. So we can use the header, which is this is a greater than sign, as a way to tell the software say this is one sequences. So I'm going to first put the mutant there, this AG29. Then go back to the APE to find out the AG29 protein, mutant MSH2, and then just highlight all the sequences, protein sequences, make sure that only protein sequences are highlighted. Copy, then I go back to the alignment window and just paste everything there. And the paste is probably in edit, and then paste. Then I'm going to input the wild type, which is wild type MSH2 sequences. I again use a greater than sign. This is start of the new sequences. Go back to the APE. This time make sure you highlight a wild type MSH2 sequences. So highlight everything. So I highlight all the wild type sequences. Then copy. Goes back to the browser and then select paste. Now I should have everything ready. And at the bottom of the screen should be a submit button. Click submit. This will do the alignment. Alright, the result is back. So this the software can also highlight the amino acid in different colors. Maybe that's more pleasant to look at. And then we just scroll down to look for the mutations. The mutation is here. So this is 540, 41, 42. At the bottom, that's the wild type, MSH2. At the top is AG29 mutant. So the mutation is in position 542. And the mutation is from R, which is arginine, to P, which is proline. So here we have a mutation which is the from arginine to proline. It's pretty serious missense mutation because proline will disrupt the secondary structure normally, and R is originally is a charged residue, but proline is a circular one. So the mutation is the position 5, 4, 2, and the change is from arginine to P. So originally it's arginine, and now it's changed to proline, and this is R542P mutation.